Okay, what is the linked list? A linked list is the most used data structure of the arrays, and it contains a group of nodes. That node is a chain of nodes, okay? And that node has only the two features, which is the value and the pointers to the next node, okay? And data linked list is the dynamic linear data structure, and it can, during the runtime, it is easily grow and shrink, okay? And we have two kind of linked lists, and firstly we have a single linked list. Also, this is the simple linked list. Whenever we speak linked list, it means this is the single linked list. And also we have a double linked list, and we're going to speak about the deep and dive each of them step by step. And firstly, we're going to speak about what is the linked list especially. Yes, and the linked list and the single linked list. What is this? Okay. And this is how our linked list looks like. This is the linked list and also a single linked list. And each nodes we have a data, which is this. This data and the pointers to the next node, okay? And each node has their unique address, okay? And this is, and for accessing this node, we are storing here address of the pointer of, which is the address of the next node, okay? And from the first node we can access the second node, but we cannot access from the second to the first, okay? And from the second we can access the third node, and from the third node we cannot access previous one, or this is the last node, and we cannot access any nodes whenever we reach the last node, okay? And the next, which is the pointer, is the none, okay? And for accessing the node, for example, this is maybe I'm going to write here a node, yes. And for accessing the next node, we're gonna call the next features, which is this, okay? Whenever we call this, we're gonna access the next node, okay? And this is how. And also, for accessing the first node, we need the head, okay? And also, that whenever we speak the head and tail, and it means the last node, the first node is a head and the last node is a tail, okay? And also, for accessing this, whenever we are creating our linked list, okay, we are firstly inside the class, we're gonna create the single linked list, and firstly, we're gonna initialize the head and tail of our linked list, okay? Therefore, we are just, we are storing the head and tail, the pointer of the first node, which is the 101 here, and like this, okay? We are just pointed to the first node. This is for how we are accessing the first node. And also for accessing the last node, we have what we called, and which is a tail we have, okay? And we are storing only the last node of address, and we can access the last node. But they are not nodes, okay? They are just head and tail for accessing this node. And especially if you are seeing, it means the tail is in the last node, and the first node is the head in the first node, okay? And this is how our single linked list and the linked list looks like, okay? And we're gonna see how represented on the memory this linked list, okay? And we have the memory, yes, and each cells we have, and we are not gonna speak about the cells, what is the size of cells, because the linked list, and it takes more memory than arrays, okay? For example, even we are storing the same type of data. For example, I'm storing here, and for 3 and 5, yes, and 9, yes, I'm storing these three numbers, integer numbers. Whenever we are storing these numbers in the array, for example, we are using maybe some type of data, yes, some type of memory, yes, we are using only, for example, and 12 byte, yes, 12 byte maybe, yes, and we are using 12 byte because each numbers required 4 bytes, okay? Therefore, whenever we are storing these numbers in the linked list, and we need more memory, okay? Then and therefore I'm not going to speak about this memory. We are going to speak how they are represented on the memory, okay? And because every nodes we are storing, for example, here I'm storing 3 and also 200, okay? Which is whenever we are accessing the first node, and after that, for accessing the second node, we need the address of that node, okay? Therefore, whenever we are storing this node here, and whatever we are storing, and they are not, the linked list, the location, the representation, the linked list on the memory, and they are not sequentially, okay? They are storing, for example, we are storing here the first node, and the second node, and maybe here, for example, the 5 I'm storing, and with 309, yes, like it looks like this, okay? And also we are storing the last node maybe somewhere on the memory, okay? Here maybe it's 9, and the -1, which is the -1 is the none. Also there is the none and none. Okay, here the pointer of that last node is a none, and this is how our linked list is represented on the memory. It looks like this. Okay, and also for finding some value from inside the linked list, we need to iterate all entire linked list. Okay, entire linked list. And for example, I'm going to iterate. I'm going to find a 5. Okay, and in the array, and I need to write like inside a square bracket. I need to write, for example, index of this is, I need to access this, yes, and if they're arrays, I need to write that 1, yes, and then I can immediately access that 5. Okay, if I know the index, I can access immediately, but in the linked list we cannot access. Okay, indirectly, we cannot access directly, and instead I need to iterate entire linked list for accessing whatever I want. Okay, and this is how our single linked list looks like. And we're going to create single linked list in using Python, and we're going to create multiple functions, and for deleting our linked list, for iterating, and adding, inserting, yes, and searching and finding some you know, we're going to create a search function and pop function and append function, yes. And I know at the end, whenever we wrote all the code of linked list, we're gonna speak about the time and space complexity of the linked list. Okay, let's do it. Okay, we're gonna create our single linked list class, and firstly we need to create our node, yes, with the init function. We just initialize the value and the next and the features, and after that we're gonna create our single linked list class, and inside we are defining firstly initializing head and tail, and after that we're gonna create multiple functions, yes, for our single linked list class. Okay, let's create it. Firstly we're gonna write our node, and inside we just define the function with init, and just takes the self parameter and also the value, and inside the self dot value is equal to value, and then the self dot next features is equal to none. Okay, and then here I'm gonna create a singular linked list class. Okay, and this class, the singly linked list, and inside we're just initializing our nodes head and tail. Okay, our list. Okay, the firstly it is the underscore init, and with self parameter only. Inside just write self dot height is equal to none, and the self dot tail is equal to none. And after that I'm going to create multiple functions. Firstly we need to create 2 functions for iterating and adding some value to our linked list. Okay, we're going to create our iterate function and append function. Firstly I'm going to write iterate, and self parameter. Inside first we're going to check if self dot height is none, and it means there is no any nodes inside. We don't have any list inside. Okay, and it means there is no any list exists. Therefore we just print the inside the quote the list is not exist, and like this. And if not, there is some nodes, yes, and if our linked list exists, we just iterate. And firstly we need to take the node value. We are just defining a node, and then we just accessing the first node with the head self.head, and after that we are just iterating using a while. Whenever node exists, yes, whenever node is none, you know, whenever we reach the last node, and the last node is none, which is the last node is none. Okay, and after that our while loop is stop. Okay, inside I'm going to write while, and I'm just printing, just print and the node dot value like this. Okay, value, and after that I'm just write node is equal to node next. Okay, next, like this. And whenever we reach the last node, yes, and the last node dot next is the none. Okay, next parameter whenever it's here, okay, is a none. Therefore whenever we reach it, the last node, it is the while loop stop. Okay, here, and like so. And this is our iteration function for our linked list. And we're going to create also one more function, which is for adding this value to our linked list. And I'm going to create append function, append,
and it takes the self and also value. And inside, firstly, we need to create instance of node, okay, with the new node underscore node is equal to node, which is our class, okay. Inside the parentheses in the argument, I'm going to give the value, okay. And after that, we need to check our linked list if there is the inside a new node or not. And for using the if self dot hit is none, it means there is no any node. We just write the self dot hit and is equal to the new node, okay, the new node, our node, and also self dot tail, also this is the new node, is equal to self dot tail is equal to new node, like this, okay. And because there is no any list and there is no any node inside the list, and we are just creating the self dot head and self dot tail, also new node. And then if there is else and else there, if there is some nodes, yes, we just add to the end of the nodes, okay, because append function add to the end, okay. And for firstly we need to write a new node dot next, yes, and is equal to none, which is the new node dot next is equal to none. It means that this node, new node, is the last node, okay. And after that, I'm going to write a self dot tail and dot next is equal to new node, okay, a new node, and also self dot tail also equal to new node. And this is for this we are just adding to the end of the nodes to this new node, okay. And this is how our append function looks like. And we're going to check our append function. Firstly, we need to create our instance of linked list, and using the singly underscore linked list, yes, this is equal to singly, which is this single linked list. And after that, I'm going to access the append function dot append, yes. And firstly, we need to give the value, for example 1, and we're going to give multiple value, and 4 also. After that, I'm going to call the iterate function. We need to iterate our linked list, okay. And this is, let's open the terminal and write the python .py, and like you can see, we added all values to our linked list, and also we iterated, you can see here, okay. And also we're going to create our next functions also, which are the insert function by index. We can add the value from, for example, to the middle or to the beginning or somewhere where we want, okay, by using the index, okay. We're going to create that insert function also, and I'm going to define a function with insert, which is the insert function takes which is the self parameter, and then the value and index also, okay. And inside I'm going to create firstly instance of node, which is the instance of new node, and new node is equal to node, and which is going to give the value. And after that, firstly we need to check how we checked here. This is the same code. We're going to copy and paste it here, because this code is the same, because we need to check if there is no any nodes. Yes, we need to add to the beginning, and also head and tail is equal to the new node, like this. And if there is the nodes, in this case we have 4 nodes, yes. If like so, we need to write the logic. Firstly, we need to check the if the index is equal to 0, yes. Inside, firstly, I'm going to write a new node dot next, yes. Dot next is equal to self dot head, like so, and then the self dot head, yes. The self dot head is equal to new node, like that, new node. From this, the new node dot next is equal to self node, which means in this case, whenever we are adding new node to the beginning, if the index is equal to 0, it means we are adding the here, and the first node, which is the 1, will be the node dot next, which is we are accessing the second node of new node, okay, is equal to 1, and the new node is equal to first node. It's being the first node, okay, here. This is whenever index is equal to 0, this is how our logic for adding to beginning. If not, else. And we need to write, firstly, we need to we are not define the temporary node, which is the temporary node is equal to, we are just accessing the first node, self dot heat, okay? And after that, we need to iterate our entire linked list, okay? And the first thing, I'm going to define the iter count, the one variable is equal to 0, and the while using the iterate for iterating. And here I'm going to write iterate count whenever less than index and -1, and it will iterate. And here, and we need to write like this: temporary node is equal to temporary node dot next. For every time we are we are accessing the next node, and we are giving the new temporary node. And then for this, we are accessing the next node, and next node we are iterating. And also every time we are incrementing iter count and iteration count, and the iterating count is by 1, we are incrementing like this, okay? And outside the while loop, I'm going to define a new variable, which is the next node, and is equal to temporary node dot next, okay? And then here I'm going to write temporary node next one is equal to new node, and which is the temporary node dot next is equal to, which is the new node whenever we are adding this node, okay? And here, and after that, I'm going to write a new node dot next is equal to next node, which is this, the next node. And the logic looks like this. If you look at here the terminal, and here whenever we are adding, for example, after 2, yes, and firstly we need to update the reference of the 3, yes, because we have a reference in the 2 nodes, for example here, and whenever we add for example after 2, and where we can add the 5, yes, and firstly we need to update the reference and of this node, and then the new node, the reference to the next node is equal to this node, okay? Whatever we are looks like, and whatever we are writing here looks like the same, okay? And this is how our insert function looks like. And we're going to check this function, save it, and after append, I'm going to write a singly linked list dot insert, okay? Insert, first we're going to give the value, for example, I'm going to give the 8, and the index, maybe we're going to give the 2, okay? And let's save it and open terminal, run it. If you see there, I added after 2 the 8, okay? Here is 8 added successfully. And this is our insert function looks like. And also we're going to create our next functions also, which is the next function is the search function, okay? We're going to create the search function also for searching, and here I'm going to define the function, which is the search for searching, and it takes the self parameter and the node value, okay? Node value, and inside, and first we need to check, and if self dot head is none, and inside we need to print, and which is there is the empty, there's no any list, yes, if there is no head is equal to, and there's no any list exists inside the linked list, okay? The list is not exist, like this. And after that, I'm gonna write the else, and it means we have some nodes inside. If like so, we are just iterating our linked list. The node is equal to, which is we are accessing the first node, self.head, and then while the while node, and whenever node is none, which means that I'm going to write here if the node dot value is equal to node value, yes, whenever this node value is this, okay, and whenever this is equal to this, and inside we just return node dot value, okay, and this is this, okay. And here, and after that, for example, and outside the if condition, if block, yes, we need to write a node, just take the node is equal to node dot next, like so, okay. And whenever we reach the last node and the last node dot next is equal to none, our loop is stop. And then after outside the loop we're gonna write if node, for example, this condition, for example, there is no any node, looks like this. For example, we give the some value is not exist in our linked list, okay. If like so, we just write the return and the value is not exist in the list, okay, the list, like so. And this is how our search function looks like. We're going to check it, and after that, after insert function, I'm going to write a singly linked list dot search. We're going to give the, for example, we're going to search the 3, okay, and the first layer. Let's also print it. This is a print, and we'll just comment this one and open the terminal. As you see here is the 3 is printed. It means we are this 3 is exist. And also let's give the 30, which is not exist in our linked list, and the value is not exist in the list. It looks like this, okay. How this is our search function. And also let's rewrite the deletion function, which is the pop and delete by index and delete entire, which is the 3 function we're going to create. And okay, we're going to create our firstly pop method, and then after this I'm going to define the function, which is the pop with self parameter, and inside here also we need to check if self dot, always we are checking the self dot hit, which is because maybe we don't have any nodes inside. Yes, we need to check it, okay, is none. We need to print the list is not exist, the list is not exist, and else, and here, and we're going to write the logic our, and we need to delete from the last, okay. And firstly, and we need to write inside the logic. Firstly, we need, for example, if there is the self and the head and tail is equal to each other, and if self dot head is equal to self dot tail, if like so, it means we have only one node. Yes, if like so, and we need to write self dot head is equal to none, and the self dot tail is equal to none, okay, like so. And whenever we wrote this, we are just disconnecting all the reference, okay, to the one node. There is no any reference to the nodes. It means there is no any node, and the reference, the garbage collector, will automatically delete that nodes, okay. And if not, for example, else we don't, for example, if not there is the more nodes, yes, we need to iterate our linked list. Node is, we're just accessing the first node using the self dot head, yes, and after that I'm going to iterate the while the node, yes, and then here I'm going to write if, and this is the, whenever we reach the last node, we're going to break our while loop, okay. And if that's the firstly node dot next, okay, next is equal to self dot tail, it means we reach the last node, and after that we're going to break our loop. And also, and we're going to write outside the node is equal to node dot next, and outside the while loop we're going to write, which is we're going to delete the last node, okay, which is the node dot next is equal to none, and also self dot tail is equal to node, okay. And whenever we wrote this, and the last node will automatically delete it for this, and there is no reference. Yes, we are just updating the reference, and then the garbage collector deleted that the last node, okay. This is how our pop function looks like. We're going to check it, and here after searching, we're going to delete that one. I'm going to write singly list dot pop, and here, and also we're going to uncomment this, save it from terminal, and you can see, and this is the last node, which is the first 4, yes, is deleted, and the last node here is a 3, okay. And the pop method is also working. And also we're going to create our next functions and the next function will be we are deleting by index. Okay, let's want to create and delete node. Okay, and here the text self and then index also, and inside firstly we are checking, and this like this. I'm going to copy this, I'm going to paste it. If like so, we are just, there is no any list exists, and if there is a some value, yes, we need to check if index is equal to 0. Yes, it means we are deleting the first node. If like so, inside also we need to check, and for example there is only one node or we have more node. If like so, if the self dot the head is equal to self dot tail, yes, and if like so, I'm going to write the self dot and the head is equal to none, and also I'm going to write the self dot the self dot tail is equal to none. Okay, and it looks like this. And then for example there is the we have some nodes. Yes, there is no one node, we have some more node. If like so, we're going to write another logic for deleting and from the first node, and then we're going to update the reference of the second node, which is the, and you know, this is, it looks like this, and the else, and the first thing I'm going to write the self, I'm just deleting the first node, which is the self dot head is equal to self dot head dot next. Okay, it looks like this, and we are just accessing the second node, and we are giving the head is that second node. Okay, head is equal to second node. It means for the first node there is no any reference. It means that there is no reference, the garbage collector will delete that node. Okay, and let's want to write from the, if there is the index is not equal to 0, yes, we have, maybe there is, we are going to add it to the middle somewhere. Yes, if like so, I'm going to write else, and the else we're going to iterate our linked list. Okay, the first thing I'm going to define a variable which is a temporary node. Okay, temporary node is equal to self dot head. We are accessing the first node, and also I'm going to define the one variable which is the iterate count is equal to 0, and after that, and while, and whenever iterate count is less than index and -1, if like so, and here we are just write the temp node is equal to temp node dot next. Okay, after that I'm going to increment the int count by 1, and outside the while loop we're going to delete the what is the index of what is the location of node. Okay, and firstly I'm going to write the I'm going to define the next node, which is the next node is equal to temporary node dot next. Okay, and then after that, the temporary node dot next is equal to next node dot next. Okay, and like so. Okay, we are deleting the what is the index, what is the location of our node for using the firstly we are accessing the next node, and then we are temporary node is dot next is equal to next node dot next, which means, for example, look at here, I'm going to delete the 8. Yes, for deleting 8 I need to update the reference of, for example, in the here, yes, in the 2 we have a reference to the 8. Yes, we need to update the reference to the not to 8 to the 3. Okay, which is the next one. Okay, and there is no any reference to the 8, it means the garbage collector will delete it automatically. Okay, this is how our delete function looks like by index. Let's want to check it, save it, and save and open the terminal. And firstly, I didn't write here, the first I'm going to write pop.delete, and here I'm going to give the index. We're going to delete that 8, okay, which is the 2, and save it and open the terminal. And oh, I made a mistake somewhere. 8. Oh, here, sorry about it. Whenever we copy it, yes, there is the one space there. Okay, let's open one more, and you can see there is the deleted. The 8 is deleted. and we deleted it successfully. And also we can delete the 0, which is the 1. Okay, you can see it is working. It is working, our functions. And okay, we're going to create our last function, which is the deleting entire linked list. I'm going to define a function def, and which is the delete and the list, which is the self. And inside, first we are list checking it. The code looks like this, and there's space, and here if there is the same logic, and after that I'm going to write on the else statement, which is that's very easy. Self dot hit is equal to none. Okay, and also self dot tail is equal to none. It looks like this. This is the delete entire list. It looks like whenever there is no any reference. For example, we have multiple nodes, yes, inside our linked list, and we are just we are just updating the reference. For example, tail, and the reference, there is no, this is the head. There is no any reference. We cannot access nodes because they are none. Okay, the pointer are none. It means there is no any reference to these nodes, and the garbage collector deleted all nodes if they haven't any reference to the head and tail. Okay, and let's want to save it, and let's going to delete, and let's delete after this the list. I'm going to update this function, and let's save it and open the terminal and run it. The list is not exist. It means that there is no list because we deleted all. Okay, and this is how our last function, which is delete all entire list, looks like. It's very easy. And we're going to see and time and space complexity of single linked list looks like. And firstly, and this function, which is this initializing, which is the time complexity is a constant, space complexity constant, iterating, and the time complexity is here. We are linear, yes. It means the here and the there is a constant. It means the iterating a single linked list it takes the, on the worst case, and time complexity linear, which is the ON, and the space complexity the constant. We are not using extra memory, which is the O1. Okay, and for adding to the end, the time complexity is the constant, and the space complexity also constant. Okay, which is there is all constant. And for inserting, this is the for inserting, the time complexity is the linear. This is here, and the time space complexity and constant. We are not using extra memory. And the searching, for searching also the time complexity linear, and the space complexity is a constant. And for deleting from the last, is the linear time complexity, and the space complexity is the constant. You see here all is clearly seen. Okay, and for deleting node by index, and it takes to the time complexity is linear. Again here the while we have, and this all the constant. Space complexity also constant. And for the last, our delete entire list is the time complexity is the constant, and the space complexity the constant. This is how our single linked list looks like with all the functions. Okay, this is how our double linked list looks like. And as you see here, the double linked list, we have we have in our each nodes we have 2 pointers, and which is the next and the previous one, and next and the previous one. Okay, and this is from the first node we can access the second node, and from the second node we can access the previous one. Okay, and in our first node, which is the previous one, is none, and we don't have any. We cannot access from the previous. We cannot access and from the first node to the previous one because we don't have any nodes. Okay, and also the last node also is the next pointer is a none. Okay, and this is the last node. From after that we don't have any nodes, but we have a previous one. Okay, which is this, which is we can access from the last to the previous one. Okay, and here for accessing the last node we are storing here is the tail also, yes, and which is here, this is the tail. And here we are just storing which is this, only this. Okay, whenever we are creating our doubly linked list, okay, we are doubly and singly, we are always we are defining the, we are initializing the head and tail. Okay, and what is the head and what is the tail. Okay, and this is our doubly linked list looks like. And also, and this is like this.
This is just tail, okay? This is not node, this is tail. This is also head, and this is not node. This is not first node, this, which is the address of 101, and the last node is the 390, okay? 390. And this is our double linked list. And also, you know, this is each, whenever we are using double linked list, and we can create another type of linked list. For example, we can create from the double linked list, which is the circular double linked list. Yes, one of the most popular one. And here I'm gonna give the brief overview what is this. And firstly, here, look at here, and this is double linked list. I hope you understand. And then you are going to create a circular double linked list. What is that? And especially the circular double linked list, and this is whenever we came this, yes, whenever we came the last node, yes, we can access from the last node to the first node. This looks like this. And whenever we are like this, and here we are storing, you know, we are storing the address of the first node, which is the 101, okay, here. And I'm just delete, and I'm just write the 101 here. And here we are storing the, which is that node, which is the 319. And this is, you know, the circular like, okay. And this is our circular double linked list. It looks like, okay. And from this we can create many, what kind of the type of linked list do you want, you can create. But we have especially the double linked list is only we are storing here none, and here also none. And whenever we are using double linked list, and we are using more memory than the singular linked list, okay? And because, you know, each node we are storing the 2 pointers, and yes, we have a value also, but we have storing the 2 pointers, okay? And whenever we are using single linked list, we are only storing the 1 pointers. It means we don't need too much memory than double linked list. But in double linked list we are using more memory than single linked list, okay? And I hope you understand clearly about what is the double linked list looks like. And after this, we can, whenever we are going to create the double linked list, a class and node, yes, what we created in the single linked list. And then we're going to create some more functions, multiple functions, which is for adding the nodes inside our double linked list, for adding the last and to the first, or somewhere here, inserting. And also we're going to create the deleting nodes, yes, how we are deleting. And also we're going to create deleting entire double linked list also, okay? And also we're going to create the iterate function. And then we're going to speak about the space and time complexity whenever we create these functions. And then you will see that exactly how it's easy to analyze the space and time complexity using the codes, okay? And let's jump into the VS Code, and we will implement double linked list in Python, yes, and we will write and we'll create all the functionalities, what is the double linked list and is required, and the append function, delete function, pop function, insert function, deleting entire double linked list also, an iterate function we're going to create, and then we're going to see what is the time and space complexity. Okay, let's do it. Okay, we're going to create our double linked list. Firstly, as we created single linked list, like this same approach for this, but some logic will change. And firstly want to create our class, which is node class, okay, and then node, and inside we just define the init function as like before, and also with self parameters and also value, okay. Inside I'm going to write a self dot value is equal to value, and then self dot next is equal to none, and after that self dot previous one, okay, which is none also. The only difference between this double linked list node and the single linked list, the difference between here, we have a previous one also, okay. In every node we are storing two pointers, which is the first is the previous and the next point to the first. For example, and you know, this is the accessing from the second node we can back to the first, and then we can go and from first to second like this, okay. And the difference also between the nodes and like this, okay. And for this we are going to create our double linked list class, okay, doubly linked list. Inside we just create as like before, just like def init function, and there is self parameter. Inside I'm just write the hidden tail is a none. I'm going to give
to the self dot head is equal to none, and the self dot tail is equal to none, and like that. And we're going to create our iterate function, which is for iterating. You know, the iterate function is like what we wrote in the single linked list, as like the same to the double linked list also, okay, for iterating. I'm just define a function with the iterate, okay, and with self parameter. Inside we just check as like before, self dot head if is none, okay, and I will print the list is not exist, okay, like this. And if not, the else. And inside I'm gonna just define the node variable to the I'm just give the self dot head, which is I'm just accessing the first node, and after that I'm iterating using the while loop, okay. And the node, whenever is this node is null, it means this the while condition is it returns the false. It will not access inside the loops, okay. And inside I'm going to write a print, and with just every time I'm printing node value, okay. And after that the node is equal to node dot next, like this, okay. And this is how we are iterating our double linked list. It's like the same for double linked list, and a single linked list is the same the logic for iterating in the linked list, okay. And also here we can reverse iterate, okay. It means we can iterate from the last to the first, like reverse, okay. Let's we're going to write that logic also, that function also. It's very easy, you know. And the reverse and iterate, and we self. Okay, here we're going to write the same logic how we write for iterating our double linked list, and here I'm going to write the same logic, but some changes I'm going to change, which is the we are not giving the first node, but instead we are going to access the last node with node dot tail, okay, which is the tail. I access the tail, and I'm going to every time, you know, for not next, I'm going to call the previous one, okay. And then from last to the first I can iterate like this, okay. And we can save, and then we're going to create our next function, which is for adding to our linked list, to the double linked list. For using, I'm going to create the append function, okay, append, and with self parameter, and then we're going to give the value. And here firstly we're going to create instance of node, which is the new node is equal to node s. Inside I'm going to give the value like this, okay. We just created the instance of node, and then we write if condition as like how the single linked list we wrote the logic, the same logic, but here is the sum. We're going to change this, some line of code we're going to add, and then to that logic, okay. And firstly we're going to check the self dot head is none. If like so, it means there is no any nodes, there is empty, and if like so, I'm going to new node, write new node dot previous one is equal to none, and also new node dot next is also none, okay. And here, because you know this is the pointers of every node, it means that we don't have this is the nodes only one, we don't have more nodes. It means if we don't have more nodes and we don't have any reference to the next node or some nodes, therefore it means the previous and the next pointers are none, okay. And then the self dot head is equal to new node, which is the self dot head is equal to new node, and the self dot tail also is equal to new node, like that. And if not, for example, inside if self dot head is exists, and it means we will write else inside else we're going to create our we're going to add to the end, okay. It means the new node dot next is equal to none, and the new node and the new node dot previous, since the previous is equal to self dot tail, and like that. And after that I'm going to access the self dot tail, and then next, which is we are accessing next. It means, you know, whenever this one is null, every time none, and whenever we are writing like that, and whenever we are defining some value, it means whenever to the the end, which means the last node. After that we are adding something, we are going to do something. It means here we are just adding new node. Yes, we are just giving like this. It means after that we have some nodes, we are giving the pointer that node. And then self.tail is equal to new node. It means the last node is also tail, like that. And this is all about append functions. Let's save it and let's going to check. And firstly I want to create here instance of double linked list. Okay, doubly, and the linked list is equal to double linked list, like so. And here firstly we're going to call append function, and we're going to give the value, for example 0 maybe, and we're going to give 1, and we're going to call more times 3 and 4, and like this. And then I'm going to iterate our double linked list using the iterate function. We create the iterate function also. Okay, and let's save it and open the terminal and I'll write the Python and dll.py, like so. And you can see here is all value is printed. We added five numbers, yes, to our double linked list is printed. And also, here we can iterate from the reverse, using the reverse iterate from the last to the first. Let's want to do it reverse iterate and save it, open, like this. Okay, from the 4, 3, 2 and to the 0. Okay, from the last to the first. Okay, you can easily do it using this. And then let's want to create our next functions also, which is the insert to the beginning or to the middle somewhere. Okay, using the insert function we can do it. Let's using the firstly we're going to create that insert function. Yes, using def insert, and firstly we get a self in the parameter and the value. After that we will give the index where we can add that value. Okay, and inside firstly we're going to create our node, new node is equal to node in the parentheses. I'm going to give the value, and like so. And after that, the first thing here we were going to check is like we're going to check this, the condition, which is we can copy this code here and we can paste it here, like so. If there is the head is none, we can write it means there is no any nodes inside. We're going to create the first node like that. If not, for example, inside if there is some node, it means we here the else statement. We're going to check if index is equal to 0, it means that we must add to the beginning. Okay, which means the new node, and the dot previous is equal to none, and the new node dot next is equal to self dot head, like this. Okay, and here it means that we are adding to the beginning of the linked list. That we are adding, it means that the first node, it means the previous one is none, therefore we are just writing this one. And after that, next node, it means the self head, which is the whenever exists the first, before adding this we can access the first node like this. Okay, and after that I'm going to write the self dot head. Okay, dot self dot head, and previous is equal to a new node. Okay, and like this. And after that I'm going to write the self dot head is equal to new node. Okay, and after that, for example, index is equal to some value. For example, we're going to add to the middle to somewhere. Yes, for this we're going to write else. Inside else we got just iterate our linked list. And firstly I'm going to create temporary variable underscore temporary node, yes, is equal to, which is the self head. Okay, self dot head. And I'm going to create the iterate function. If you remember, we created like this whenever we created a single linked list. It's like this. Okay, we just create how we create and the single linked list is a count is equal to 0, and we're going to iterate using while and the node. Whenever here I'm going to write the iterate count whenever if is less than index, and the index -1. Yes, if like so we are iterating every time. And here inside the temporary node is equal to temporary node dot next. We are iterating like this. Okay, we are accessing the next node every time, and every time we are incrementing iterate count also by 1, like that. And outside the while loop, we have write the logic for inserting middle to the whatever index is. And here I'm going to write the new node dot next. Yes, like this. Next is equal to temporary node dot next. Okay, and here you just taking the, this is the new node dot next. It means we are updating we are adding here's a new node. After a new node, we are just taking the temporary node dot next. Okay, and after that, I'm going to write the new node, the previous one, which is we need the previous one also, which is we must update the two here. Here whenever we updated in the single linked list, we just updated the next one. But in the doubly linked list, we must update 2 pointers, which is the next and previous one. And also we're going to take that one also, which is the temporary node. Okay, and after that, and a new node dot next and dot previous one is equal to new node. Okay, which is the new node. Whenever we are adding here. Okay, after that, and here and the temporary node, after that I'm gonna dot next is equal to new node, like this. Okay, and here I'm just take that one, which is the new node, to the next dot previous. And also here the temporary node dot next is equal to new node. Okay, which means whenever we have that temporary node, and after that, whenever we are writing like in here, we are accessing the, for example, I'm going to add after 2, yes, inside, if you see the terminal, I'm going to add, and after from the, for example, I'm going to add value after 2, yes, and firstly, I need to update the here and here all the references. And here is the temporary node dot next, which means, and the temporary in the here, the temporary node, it means the 2. Okay, and dot next is equal to new node. It means after that I'm adding the new node here. Okay, and like this. And this is how our insert function looks like. And let's save it. Let's save it and let's check it. Firstly, after append function, I'm going to access dot insert, and firstly we're going to give the value. For example, I'm going to give the 8, and in the index, we're gonna add the beginning, and let's save it. Let's write, and as you see, because here we are iterating from the last to the first, and this is the last element, this is the first element. Let's gonna iterate from the first to the last, and like that. And if you see, this is the 8 in the here at the top. Okay, and we're gonna add the next function, which is the search function. Which is the firstly we're going to create a define a function, which is the search, and here we're going to give this firstly we're going to self parameter. After that we're going to give the node value, okay, which is the node value, and inside the function firstly, and we're going to check the hit, which is the if self dot hit, and the if is none, this is none, yes, it means there is no, any nodes, yes, it means we're going to print the list is not exist. The list is not exist, like that. And if not, else, and I'm going to write the logic, which is the node is equal to self dot hit, which is how our previous function looks like the same. We are just iterating. Yes, we're gonna firstly here I just access the first node for iterating, and after that I'm going to use the while loop, which is the whenever node is, here we can write like this, and whenever node is none, and our while loop is stop, and whenever is some value, it will iterate all entire linked list. Okay, and inside firstly we're gonna write the if condition, if, which is the node value, if the firstly self. Inside firstly we're gonna write if node dot value is equal to, which is the node value on the parameter, which is this one. Okay, and this, if like so, I just return node dot value. Okay, and like this. And after that, outside the if block, I'm going to write the node is equal to node dot next for iterating. We must write whenever, if not, we are iterating that we are just jumping the next node like this. Okay, and outside the while loop, and I'm gonna, if there is no any something, for example, outside we didn't find whatever we are searching, yes, if node exists inside the entire linked list, it means we're going to return and the message, which is the value is not exist in the list. Okay, the value is not exist in the list, like this. And this is how our search function looks like. Let's save it and let's check it. And firstly, after inserting, I'm going to check and I'm gonna write double linked list and dot search, yes, like this. And first we're gonna give the node value, which is I'm gonna search, which is the, let's want to search the 3. In this case we have 3, yes, and we're gonna save and open the terminal. Let's run it. There is the, oh, we must print that our, because here, you know, we are just returning, we need to print our this code, print using the print function, okay, and like this we just comment this, we don't need for now. And let's check one more time, and you see here is 3 is returned, which whenever we have. And if for example we have, let's gonna enter the 30, which is will not exist in the list, which is the, let's enter the value is not exist in the list. Our search function is working is correctly, and let's want to create our pop function, which is using the, firstly I'm going to define the function, which is the pop, for deleting from the last of our double linked list, and it takes only self parameter, okay, and inside, and we're going to write the logic how we wrote in the in the single linked list. It looks like this, and also we can self change, we're going to make some changes, okay. The first, if self dot hit is none, yes, is none. If like so, it means the list is not exist, and we're gonna print the list is not exist. I'm gonna return this one, and if not, else I'm gonna write, if not here, I'm gonna check the if the self dot hit is equal to self dot tail, okay. It means we have only one node in our linked list, and if like so, we will we'll write self dot hit is none, okay. And we are just we are just disconnecting, we are just deleting updating the all references, because this, whenever we are writing self dot hit is none and self dot tail is none, it means there is no any reference in the node. It means the garbage collector will delete it. Self dot tail is equal to none. In this case, we have a first node, only one node. We are just doing, whenever our self.hit is equal to none, and also self.tail is equal to none, it means the all reference we updated to the none, and also we don't, and in our node will delete it from by the garbage collector is automatically, okay. And if, for example, if not the else, there is no only one list, there is a lot of lists, a lot of nodes, yes, maybe, and we're going to write the logic, which is the self.tail, write the self.tail, I'm going to access the tail, and is equal to self.tail dot previous one, okay. I'm just accessing the previous one, and then the self.tail is dot next, self.tail is next is equal to none, okay, which is none. If like so, the last node will delete it, because whenever it's self.tail is equal to tail dot previous one, which is the previous one, yes, it means the self.tail is deleted, okay, and self.next self.tail dot next is equal to none also, okay, which means in this case previous one has the whenever it's previous, for example, we have a previous one, yes, for example in this case the 3, yes, and the 3 the pointer is this, yes, for the 3 can access the 4, yes, and whenever we deleted 4, it means in the 3 we can access we have a pointer, a next pointer, okay. We need to update that next pointer to the null, which is what we are doing here, okay, and it looks like this, okay, which is this is all about the pop method. And let's want to check our method, okay, and first I just want to delete this search function, and after that I'm going to write a doubly linked list dot pop, which is the deleted, and also I'm going to comment this and save it. Let's want to run, and if you see here is the 4 is deleted, which is the 4, okay, and we can delete from the last, and also we can delete one more time. Let's copy this and 2 times, and let's see it. As you see, there's 3 also deleted, and like this, okay. And also we have a delay, we can delete by index, how we wrote in the single linked list, we can write like in here also. And we're going to write, that here whenever we are writing the code, the logic is the same, yeah, that we are checking this and we are doing this logic, but here there is some changes, some we are making some changes, which is the next dot previous, which is we are because in our node we have 2 pointers, which is the 3 parameters, the previous one and the next value and the next one, okay. Therefore we are doing some more extra job, okay, whenever we are writing the Doubly linked list code, okay. All right, let's go overwrite and delete and deleting for by index, and for doing find the delete function and delete by index and delete a node, okay, by index. And firstly here that we're gonna just write the self and then only index, okay. Here you're gonna write index, and after that inside this first I'm gonna check if self dot head, yes, is none, if like so, and inside we just print the list is not exist, like so. And if not else, I'm gonna write this inside. In the first line we can write one more double, which is the if condition, which is the if our index, if index is equal to 0, it means we're gonna add the first, oh yes. Inside I'm gonna write one more if condition, which is the for the self dot head if equal to self dot tail, which means, and the if like so, you know, it means inside the linked list, inside our Doubly linked list we have only one node, and therefore whenever for deleting that one we're going to use the self dot head is equal to none. We're just updating the, no, this is, it means the self dot head is equal to none. We will not access the first node. It means when there is no any reference to the first node, it means, and garbage collector automatically deleted if there is no any references and that object. It means, you know, whenever we are storing that all nodes, it means they are object, okay, because, you know, we are creating all class and also that they are in object, okay, our nodes. And after that the self dot tail is equal to none, like this. And if not, they are not equal to each other, it means we have more, one, for example, from the we have 2 or 3 nodes or maybe more nodes, yes. For this case I'm going to write else, and inside here I'm going to write the logic, that is that we just delete the first node, okay, and then just update for the next node to the first, and also they are the pointers also, which is like the self dot head, yes, is equal to just the self dot head dot next, okay, and it means the next self dot head is next, which is we are accessing the second node, okay. And also whenever we write the self dot head dot previous one, which is the previous one, is equal to none. And it means, let's want to see, I'm going to delete the 0, yes, it means I'm deleting the first node here, and it means whenever I'm deleting first node, and this 1 will be the first whenever after deletion for 0, okay. It means in this case 1 we have pointers, which is we can access from 1 to the 0, okay, because in the Doubly linked list we can access from second to the previous one. In this case, the previous one is equal to the first node. Okay, from the previous we can access to 0. And if we are deleting the first 0, we must update this, which is the head dot previous one is equal to none, okay, which is this one. What we are doing this here, okay. And after that there is no any reference to the 0, the garbage collector will automatically delete that one, okay. And this is if there is the index is equal to 0, how our code looks like. And if not, and else, yes, here I'm going to write else, and here firstly we're going to define the temporary, which is we are going to, the temporary node, and here I'm going to iterate my entire linked list, okay. And I'm going to give the self dot head, we're just accessing the first node, yes, like this. And after that I'm going to create a variable for storing the iteration count is equal to 0, like this. And then I'm iterating using a while loop, and whenever iteration count is less than index minus 1, yes, like this, inside we are just write the temporary node is equal to temporary node dot next, and then I'm going to increment our iter count by 1, okay, like this. And outside the while loop I'm going to write the logic for deleting, that is what is the index is, okay. For this I'm going to define, I'm going to write a temp node dot next and is equal to temp node dot next, next dot one more next, which is we are accessing that. And after that, and here this is the temp node next, it means we have a next node, and after that there is the third node. We are just updating for example, we are deleting this one, and here whenever we are deleting 8, yes, we are updating the second, the previous, which is the next node, and which is the 3 is the previous. This is we are updating 2 at the pointers, okay, the 2 nodes, which is this one, okay. And whenever we are writing this, we are accessing from the second which is the 3, and also we are accessing the next node is not equal to that node is this of next node is equal to this node, therefore we are writing here. Okay, and after that I'm going to write the temp node dot next dot previous one is equal to temp node itself. Okay, and which is the this is the previous one is equal to which is this temp node itself. Okay, and this is how our code looks like for deleting by index of the node. Okay, let's save it and let's run it. Firstly I'm going to write here which is the double linked list dot delete node, and here I'm going to give the index. Let's we're going to delete 8. Okay, and which is the 8 is that 1 2 3. Okay, which is the 3 here, the 3, and save it and open terminal. And from C you see there is 8 is deleted. Also we can delete whatever we want, for example 1, which is it will be deleted this one. Okay, and you see this deleted. How this is deleting function by index is working correctly. And also the last function, which is the deleting entire our list. Okay, our double linked list. For doing this, and I'm going to define the function deleting the list. Okay, list, which is the self only, and inside I'm going to write the logic. And for deleting the single linked list, for deleting the entire list, we didn't iterate all list, but in this case in the double linked list we must iterate entire, because for accessing the last, because we are deleting all, therefore we must iterate all, and we must update every pointers. Okay, and therefore we're going to iterate the firstly. Let's write the first logic, which is the self dot hit if is none, yes, like always, and we're going to print the list is not exist, like this, and else. And I'm going to write I'm going to define the temporary node. Okay, is equal to self dot hit, just accessing the first node, and after that I'm going to iterate using the while my node, which is the temp. Inside, firstly, firstly I'm going to write the temporary node dot previous one is equal to none. Okay, is equal to none, like this. Okay, and after that I'm just iterating like this, temp node dot next, like that. And outside the while loop, and I'm going to write the self dot hit is equal to none, and also self dot tail is also equal to none. Okay, like this. And this is how our delete the list, entire our linked list. Yes, and this is the same sound looks like the previous, which is the single linked list, but here we are iterating, and every time we are updating previous pointers every nodes to the none. Okay, and whenever we reach the last one, which is the while loop, is stopped, and after that we just define the head is none and tail is none, and all references is we updated, and whenever how many nodes is there is garbage collector is automatically deleted. Okay, and this is all about double linked list. Let's want to check and delete the list, entire list also, the save it, and here, and for delete we are going to delete the list, and like this. Okay, and let's check it. If you see here is the list is not exist, which is whenever we are iterating, if the iterate function, if the list not exist, we print the message, which is this message. Okay, and this is how our delete function looks like. Let's want to see how the time and space complexity for double linked list. And firstly, the iterating the double linked list is the time complexity on the worst case, which is here is the linear, and others are all constant. It means the time complexity is the linear time complexity on the worst case, which is the ON, and space complexity is the O1, which is that constant. We are not using extra space, extra memory. Okay, and reversing the iterate, iterating from the first and from the last to the first, from the first to the last, the same. Here also the ON time complexity and the space complexity the same, the O constant. And here appending, there is appending and to the last, which is the constant time, and O1 on the worst case, and also the space complexity. Also, we're not using extra memory, and this is the constant time operation. Okay, and inserting to the middle or to the beginning somewhere. Yes, for doing this, you see there is the all constant, and here we are iterating. It means the time complexity is linear time complexity, which is the ON, and the space complexity we're not using extra memory. It means this is the O1. For searching, the searching also we are just here, if you see it, obviously the scene, and this is the time complexity is linear, and O1 that is the ON, which is the linear time complexity on the worst case, and also space complexity. Also space complexity is the constant time, okay, because we are not using extra space. And popping, which is the deleting from the last, which is the constant time complexity, and also time complexity constant, and the space complexity also constant O1, okay. And deleting node by index, and this is all here is the constant time, constant, and only here is we are iterating. It means the linear time complexities. Time complexity is linear, which is the ON, and the space complexity constant. And deleting entire list is the time complexity is the, here we are iterating, it means the linear time complexity ON on the worst case, and the space complexity also space complexity is equal to O1, is the constant time. We are not using extra memory.